Hello, this is a video to demonstrate the effect of initial porosity on mobilization of debris flows due to changes in pore pressure upon mobilization. So, I have in front of you a beaker. It's a rather large beaker. There's my hand for scale. And it has in it a mixture of sand and gravel and a bit of water. The water, or the, so we can see the level of the water. And I'm going to go ahead and mark that with a water-soluble ink pen. And I'm also going to mark the level of the stuff, solid, gravel, sand and gravel in there. And that mark should be gone. All right. Make that a little better, maybe. Goodness, it's awful. What happened to my marker? All right, well, it's at the 2500 mark. So this is an initially unpacked matrix, whatever, unpacked pile of stuff. And what we're going to see is what happens to the water level when we shake it. So I'm going to shake it. All right, shaking commencement. All right, now what you may have noticed already is that we have a big change in the water level as well as a change in the level of the sediment. So the sediment has moved from up here at 2500 down to, put it roughly here. The water has changed quite a bit, gone nearly doubled in its height, gone from about 1200 here up to nearly 2000, say, call it 1800 maybe. So the effect there is that pore pressure is not due to the mass of the water, it is due to the height of the water above a point. So the pore pressure down here at the bottom, after shaking, has increased by nearly a factor of 2. So now I'm going to compact the sediment. I'm going to do that carefully so that I don't break this nice beaker. Probably need to get rid of some of that water. So there's our compacted and slightly decanted, having removed a little bit of the water. And so I'm going to again mark the initial water line and the initial material line. All right. Now I'm going to shake it again. All right, let's do some shaking. The effect this time is a lot more subtle. That is, water level barely changed. I mean, maybe it's changed. So what was the point of all that? Well, if I have some material, something like this, on a steep slope, and it rains enough for the pore pressure to get high enough for a landslide to occur, that is failure, initial failure, well, what happens when it initially fails? It moves and it shakes. So if I start with an initially dilate material, such as I started with the first time here, once it moves, it shakes, it settles, and the pore pressure rises, and sometimes quite dramatically, as we saw here. And so what starts off as an initially creeping landslide, once it moves a little bit and the pore pressure goes up, it essentially liquefies and accelerates rapidly as a debris flow. On the other hand, if I start with an initially compacted material and I get it wet enough, pore pressure high enough, for it to slide a little bit, well, once it shakes, if anything, it's already compressed, and so it has to dilate in order to move, and the water level drops, maybe a little bit decreased. And once it drops a little bit, then the pore pressure is then too low for it to continue sliding, and so it stops. And so that's why when you start with an initially low porosity compacted material, you tend to get a slowly creeping landslide or earth flow that moves bit by bit instead of accelerating as a debris flow. And another thing, I wanted to show that what happens when I shake this stuff that's sand and gravel, especially when it's got water in it. I end up with a bunch of rocks at the top, and down here looks like all sand. Now, I know there's a bunch of gravel in there, but looks like, especially down at the bottom, it's pretty much just sand. So what I've demonstrated here is what I've heard referred to, I think, as kinetic sorting or perhaps kinematic sorting. And it's the reason that debris flows have bouldery snouts and bouldery self-formed levees, because the coarse material tends to sort to the periphery of the debris flow due to this kinematic sorting. Essentially, when you can think of it as, if I've got stuff bouncing around, it's going to bounce around at random, except that it's limited by its mean free path, or it's limited by its free path length, how far it can go before being stopped by some other particles. And the gravel has a much shorter mean free path than the sand, relative especially to its diameter. And so essentially then the sand tends to settle down into the cracks, and the gravel tends to go to the surface, because that's the only place where it can once the gravel gets to the surface, it tends to stay there because it can't get back in. So that's sorting that happens in a debris flow, and you can see it demonstrated here.